Thank you very much for the floor. Thanks for the invitation. So my name is Zuzana Bukovčíková. I am from Slovak University of Technology in Bratislava. Today I'm going to show you an overview of the system that uses computer vision for automated tagging in archives. We have been working on this for some times, therefore I apologize to those who have seen it or seen parts of it, but some things are new. And also I put a lot of images in the presentation, so it is at least visually appealing, if nothing else. All right, so let's get into it. It all started with data, as these things usually do. We have started with a set of 2,200 photographs. Two things about this data set. First, in digitalized version of it, we have no information, no metadata. We just know the file name. And the second thing is this data set is quite diverse. There are portraits, there are sceneries, there are correspondence, so text would be really nice. And that is what we have tried to do. We tried to make it searchable, to create those tags. It made sense to us to focus on looking for people in this data set, since this is a collection centered around a historical figure who presumably met other historical figures, and that would be nice to look at. We have ended up with a system that helps you find people and recognize them, create some automated tags on what's on the image, and also allows you to put your own tags, correct the AI tags, and filter the images through that. There has been two main problems that we have been dealing with this entire time. First, we have used deep learning, convolutional networks, and for that you need quite a big set of training data, which unfortunately we do not have. And the second thing is certain uncertainty about the desired outcome, since this is a supervised problem, meaning you give the tags the right answers to the system beforehand, and it's not always easy to know what these answers are or should be. But we'll touch more on that later. So today I prepared sort of very simple overview of the AI that's behind the system. There are 6 parts. We're going to talk about the outcome. We're going to very briefly mention the methods of the artificial intelligence that were used. And yeah, so we have 6 minutes, 6 methods. Let's get right into it. So the first thing, or the 0th thing, is pre-processing. Pre-processing at this stage was very simple. We needed to remove the unnecessary frames, sort of unnecessary framings from the image, since more framings mean more edges. Edges are not good for computer visions. We have done this using UNet architecture with some morphological operations. What is nice about this is it has quite good accuracy, even when someone is using a small training set. Now we have used a training set that's smaller than 50 photographs, and it performs really well. So that is nice. And it allowed us to move from step 0 to step 1. Step 1 is the very first basic tag we wanted to give these images. Is this a document or is it an image? Now, we had, if I may say so myself, this works pretty well. It works quite well because this is it's not that complicated of a problem, meaning it probably could be done even without deep learning and convolutional networks. There are some observations that you can have. First, documents tend to be lighter in color, or that documents usually have better defined edges on the colors. And thanks to these observations, you are able to build a decision function that can be taught to a simple neural network. And the thing about simple neural networks is that the simpler they are, the less data you need. And our network was also used on, I think, 200 images it was, which is, again, data set we were able to acquire. And by acquire, I mean create. Now, of course, we didn't these observations, we didn't define them ourselves. We could have. It would take some time and effort, and probably the accuracy would be slightly worse than it is now. We used information about the images from pre-trained weights. We used ImageNet problem data set, and we use weights from VGG19. And that looks really nice. So let's move on. We have tagged documents, images, and images. Let's see if we can tag those that have people in them, which is sort of nice if you want to look at, for example, portrait, or you want to just look at the sceneries, the streets, and so forth. This also worked fairly well. We used object detection methods derived from models trained on modern images. Since we do not have, or I do not have it, big enough training set for historical content. It performs fairly well even without any special pre-processing methods. However, the methods we have tried, mainly general adversarial networks, did show promise. They improved recall of the system quite significantly. Yeah, all right. So let's move to part 3. Part 3 is face detection. Again, we have people. We're trying to find faces, so hopefully we can also recognize the faces that are there. This is probably the part where the most of the research went, simply because it didn't work as well as we hoped. We used both traditional methods and deep learning. Deep learning performed better, of course. The problems that what we think was the problem is that faces are sort of small area of an image, and therefore we think that the corruption that comes from digitalization and age is more prominent in it. There are 2 ways to tackle this problem. First is remove those imperfections, and the second is train on with those imperfections in mind. So with those 2 perspectives, first, can we pre-process the images so that the damage is mitigated? We again tried traditional methods. We tried sort of new methods. We used general adversarial networks for this. And the second approach is we do not have a data set large enough for training. However, are we able to create it artificially? And again, general adversarial networks seem to be our friend in this case. So what we have done is we have artificially damaged new modern images, part of the training set, so that we can learn better detectors on it. Now, this is still work in progress, so it's not in the final architecture, final pipeline just yet. However, the first tests show promise, and we're very excited about them, since the use of GAN networks in pre-processing, meaning mitigate the damage, make old things look like new things, seem to improve recall for almost all models we have tried. And the use of GAN networks in training process, meaning purposefully damage part of your training set, seems to improve both precision and recall, and not only on historical content, but also on hard cases in modern images. So this is from the first tests we have done. This is, I think, true at least for the networks we have used in our training process. We're going to look more into it. Hopefully it's going to be like that. So we have found a face. Let's move on to the problem number 4, which is face recognition. Basically, we again use sort of traditional models for machine learnings for this. Pre-processing seemed to have little effect on it, so we didn't employ it. I have already talked about this before on Fantastic Futures, for example, but here is where we found the biggest problem is to define the tags, to define the problem, because there are some issues. First, if my system tells me this is the same person, I have no opinion on that. Maybe, maybe not. And the second thing is we can either bend the system so that it recognizes people across ages, or we can bend it so that it differentiates between family members. We just don't know how to do. I don't know how to do both. maybe someone can help me. So we have given up on automated recognition system. We have developed the recommendation system instead. And what it does, it recommends in two ways. First, you have an image and it kind of recommends who it could be, or you already have a person tagged in your archive and it tries to find them in different images. Right, and on to the fifth part, this is going to be short and fun. This is just some sort of byproduct that occurred while we were doing the things that I was just talking about. So as I've mentioned, we have used COCO classes for people detection, meaning are there people or is this a scenery? There are some more COCO classes that are available. For example, you can filter the images where there are dogs or where there are boats or, I don't know, birds. It's sort of fun. And the second thing is, since our recommendation system is looking at similarities in faces and doesn't make decisions, it can sort of help to curate a data set, a subset of the images when there is a specific group you're looking for. For example, in this data set, here are the images of children, here are the images of, I don't know, people with mustaches, images of women, etc. And the last thing, we didn't intend to build an automated colorization tool, and we haven't because that's hard. There's some things working against this. First, when you colorize an image, you're creating a new source, and inevitably you introduce some biases into it, and that's not that nice. And the second thing is, as far as I'm aware, GANs aren't able to do this fully automatically, meaning they still need some human supervision. But nevertheless, we use GANs as a pre-processing tools, and in the meantime, we found some pretty pictures that are maybe nice to look at. Yeah, and that's it for me. So basically, I would like to thank New Age Factory, Josef Ziviak, and my colleagues and students who participated in this. So what have changed since the Fantastic Futures is we have revamped the algorithms. We have added sort of manual tag creation and changes into that, and also the system is live, and some people are testing it, and we're hoping that it's well, that it is usable, let's say.
Thank you so much, Susanna. Are the systems you're running really designed and meant to be running in your labs or your institutions, or are they portable software, or what are the best ways for others outside of your networks to take advantage of the good work you've done?
For us, it's pretty much the same, except we're not at the stage where you can test them on your images from our lab. But yes, the hope is that it's going to be a software that can be used elsewhere.
I had it's really enjoyable talks, and Susanna, I put a comment in the chat, and talking about how to get engagement with public. I'm suddenly thinking, as we talk about it, that comparison of systems offered by institutions like yours could be done via completely different media, like the fascinating Polyakov TV series, which I suddenly recalled to mind as I was hearing you talk. In other words, yeah. Tell the public, okay, oh, this is our software, and by the way, it relates to TV.
Yes, thank you very much for the recommendations. I have put it on my to watch list, and I'm sort of excited. And yes, it's a good point. You do want to share your work with others eventually, and hopefully it's going to be ready for that soon, and it can help others to share their work using it. So